Unit 4, Lesson 5. So that's what we're going to be covering today. We have 2 vocabulary words. Make sure you look at your vocabulary sheet for the definition for both of those words. So we're going to start off with properties of rhombus and a square. So a rhombus is a parallelogram with all 4 sides congruent. All of the properties of a parallelogram hold true for a rhombus in addition to the following 2 theorems. So we got theorem 2.5 and theorem 2.6. So example 1, use the definition of a rhombus. So if LM is 2x minus 9 and KN is x plus 5, in rhombus KLMN, find the value of x. So by the definition of a rhombus, LM is going to be congruent to KN, meaning LM will equal KN. So I could take these 2 expressions and set them equal to each other. This is going to give me 2x minus 9 equals x plus 15. So I want to get x on one side. So subtract x. That gives me x minus 9 equals 15. Now I want to isolate x by itself, so I'm going to undo this operation. So add 9. I get x equals 24. So x equals 24 is the solution to this problem. We just have to find the value of x. Let's take a look at example 2. So example 2, we're going to use the diagonals of a rhombus. So the diagonals of rhombus KLMN intersect at P. So they intersect right there at point P. If angle LMN, so that big angle, is 75, find angle KNP. So you want to find this angle right down here. So we know that rhombuses, or we know that we have a rhombus. So we know angle LKN is going to be congruent to angle LMN. And they're going to be bisected by KM. Well, what's this do? How does this help us? Well, remember the bisective formula we had from before. So we know that the measure of angle PKN is going to equal 1/2 the measure of angle LKN. So that means that the measure of angle PKN is going to equal 1/2 of 75. Well, 1/2 of 75 is going to be 37.5. So PKN equals 37.5 degrees. So that's going to help us out. Now what we're going to do is we're going to take all the information we have and we're going to find that missing angle. So the measure of angle PKN plus the measure of angle KPN plus the measure of angle KNP equals 180 degrees. So sub in the values that we know. Since this is a perpendicular bisector right here, we know that that's going to be a right angle. So this is going to give us, we just found this is 37.5. As we said, PKN is 90, so it's going to be plus 90. This is the one we want to find, so this is our unknown, plus x equals 180 degrees. Actually, I'm going to just leave that as measure of angle plus measure of angle K and P equals 180. I'm just going to leave it as the angle because that's what we want to find. So add these two together. That gives me 127.5 plus measure of angle K and P equals 180 degrees. Subtract 127.5 from both sides, minus 127.5. And I get that the measure of angle K and P equals 52.5 degrees. So that would be our angle. So now we want to use the definition of a square. So we know that EFGH is a square, and we know that FJ equals 19. So we want to find, so FJ equals 19. So we want to find FH. Well, FJ is going to be congruent to the other half, JH, because it's a square. It's definition of a square. So FJ equals JH. So JH is just going to be 19. Definition of a bisector. FJ plus JH equals the whole thing, which is FH. We know what FJ is. That's 19. We know what JH is. That's also 19. Equals FH. So FH is going to be 38. Knowing that it's a square helps us out greatly there. Now we want to test for a rhombus in a square. So we got 4 theorems that are going to help us with testing to determine if it is a rhombus or a square. So review through the theorems and reference your theorem reference sheet to help you out. Let's apply this to the first one. So use the conditions for rhombus and square. So we want to write a proof that given that this is a parallelogram and knowing that the triangles are congruent, we want to prove that it is a rhombus, a special kind of parallelogram. So again, given that triangle TSW is congruent to triangle TSU, it must be true that the line segment WT is going to be congruent with the line segment UT. So WT is going to be congruent with UT. Because line segment WT and line segment UT are congruent, consecutive sides of a given parallelogram we can prove TUVW is a rhombus. By theorem. 2.19. Because two consecutive sides of parallelogram are congruent, then that parallelogram is a rhombus. Well, WT is congruent to UT, therefore we have a rhombus. So that's where those ideas help us out greatly. So there's the proof. Because of 219, and because we know that it's consecutive, it is a rhombus. All right, let's take a look at the last one. So the last one, determine whether this is a rhombus, a rectangle, a square, a parallelogram, or just nothing. It's just whatever. So I want to start off with graphing it. Well, I gave you the graph to start off with, so here's the graph. So I graphed it out for you, okay? So you don't have to worry about graphing it out. So to be a rectangle or a square, AB must be perpendicular to AD. So to be a rectangle or square, AB must be perpendicular to BD. If it's not going to be a rectangle or a square. So let's start doing some slope testing. So slope of AB is going to be 6 minus 2 over negative 2 minus negative 3, which gives us 4 over 1, or 4. Let's check the next one. Slope of AD is 3 minus 2 over 1 minus negative 3, which gives me 1 over 4. Well, by definition of perpendicular, when I multiply 4 times 1 over 4, I need to get negative 1. But in this case, I don't get that. I get 1. So because I don't get negative 1, not a rectangle, or square. Again, definition of perpendicular is that when you multiply the two slopes together, you end up with negative 1. But you don't get that in this case. You get 1, so they are not perpendicular to each other. Next, let's check a rhombus. So we're going to look at the diagonals to see if the diagonals are perpendicular. So slope of AC. AC, that diagonal right there. That's going to give me 7 minus 2 over 2 minus negative 3. 7 minus 2 is 5 over 5, more commonly known as 1. Now let's check the other diagonal, BD. Slope of BD. Well, this is going to be 3 minus 6 over 1 minus negative 2. Again, I'm getting all these points from the beginning. So this is going to give me negative 3 over 3, more commonly known as negative 1. Hey, take a look at this. 1 times negative 1 equals negative 1. By the definition of perpendicular, this is perpendicular because it equaled negative 1. So, parallelogram ABCD is also a rhombus. So we looked at rhombuses and we looked at squares. So take a moment, summarize what we've covered over this unit or this section, and then you're going to use this to help you answer the questions for today.